Yo guys, what up? Shaq here. Today we're going to be looking at rationalizing the denominator. Before you do this topic, make sure you understand the basic concepts of adding, subtracting, multiplying, dividing, and simplifying surds. If not, you should be alright, because I'll do some brief explanations here. Alright, what is rationalizing the denominator? Well, rationalizing the denominator means to get rid of the surd from the denominator. So here's an example. I have 3 over root 2. If we have a look at our denominator, there's a surd. So the goal of rationalizing is to get rid of it somehow. I'm going to show you how you do that. So there's a few ways to rationalize the denominator, and it depends on the question. So the first kind of question we'll look at, guys, is when there's literally just a surd on the bottom, alright? So how do you do it? What you're going to do is you're going to multiply just both sides by the denominator. So we're going to multiply both sides by root 6. So multiply by root 6, multiply by root 6. 4 times root 6 just means 4 lots of root 6. And root 6 times root 6 is root 36. There's still a surd at the bottom, so we're not finished yet. We got to keep going. So 4 root 6. The square root of 36 is actually just 6. Now, perhaps we can simplify. Well, now we've rationalized our denominator. There's no more surd at the bottom. It's just 6. But let's get a better answer, guys. Let's try and simplify this. Well, what we can do is we can divide both sides by 2. Both integers by 2. So 2 and 3. So our answer would be 2 root 6 over 3. And look at that, guys. There's no more surd at the bottom. Let's look at the next question. The next sort of question is where there's going to be a number being multiplied to the surd. 2 lots of root 3. A lot of people will multiply both sides by 2 root 3 and 2 root 3. But this is wrong, guys. Whenever there's a number being multiplied to the surd, all you're going to do is multiply both sides by just the surd. Multiply both numbers by just root 3. Like that. Times root 3 times root 3. So 3 times root 3 is 3 root 3. 2 root 3 times root 3 is just going to be 2, and root 3 times root 3 is root 9. Alright, we've not rationalized it yet because there's still a surd. So it'll be 3 root 3 over 2 root 9. Well, root 9 is basically just 3. So it'll be 3 root 3 over 2 times 3, which is 6. We can divide both these numbers by 3, so it'll be 1 over 2. So it'll be 1 root 3 over 2. And look at that, we've got rid of the denominator from the bottom. The final kind of rationalization problem is when there's a surd being added or subtracted by a number. What we do here, guys, is we're going to multiply both sides by root 3. But if it's plus 1, it'll be minus 1. We're doing the opposite. If it's plus 1, it'll be minus 1. And if it was root 3 minus 1, we'll do root 3 plus 1. So just the inverse. Okay? So I multiply the denominator by root 3 minus 1. I'll multiply the numerator by root 3 minus 1. And that's what we get so far. So let's expand these brackets. 7 times root 3 is 7 root 3. 7 times negative 1 is negative 7. Then I'll put this in brackets, and I'll use FOIL. I'll expand the brackets. So first, let's multiply the first terms. Root 3 times root 3 makes root 9. Outside terms, root 3 times negative 1 makes negative 1 root 3, or just negative root 3. Inner terms, 1 times root 3 makes positive 1 root 3. And then last terms, positive 1 times negative 1 is negative 1. So we've not answered our question yet because there's still surds at the bottom. So let's try and simplify. Well, we'll keep the top the same, 7 root 3 minus 7. Oh, but the square root of 9 is 3. Negative 1 root 3 plus 1 root 3 will cancel out because negative 1 plus 1 is 0. So those will cancel out and it'll be minus 1. Let's simplify even further. 7 root 3 minus 7 over 3 minus 1 is 2. So, great. We've got rid of the surd at the bottom. We've rationalized it. And let's see if we can simplify our fraction. We have 3 terms. Is there anything we can divide all these numbers by? Well, 7, 7, 2, there's nothing in common. So our final answer is literally just 7 root 3 minus 7 over 2. And those are 3 ways we can rationalize the denominators. First problem, rationalize the denominator of 8 over root 2. As you can see, the denominator just has root 2. So all we have to do is multiply by root 2. So root 2. So 8 times root 2 is 8 root 2. Root 2 times root 2 is root 4. We can simplify square root of 4. Square root of 4 is just 2. So 8 over root 2 over 2. And our denominator has now been rationalized. There's no more surd at the bottom. We can also simplify the 8 into 2. We can divide both sides by 4. Divide both sides by 2. So 8 divided by 2 is 4. And 2 divided by 2 is 1. So the answer is 4 root 2 over 1, which is basically just 4 root 2. No problem. Write 2 plus root 2 over 6 plus root 2 in the form a plus b root 2 over c, where a, b, and c are all integers. So we have this expression here. Well, I know it's a fraction, and I see there's a surd as our denominator. So this is an irrational fraction. And they want us to write it in this format, where c is an integer, a whole number. So c is rational. So therefore, clearly we must have to rationalize the denominator, turn it from irrational to rational. So let's go ahead and rationalize the denominator. So 2 plus root 2 over 6 plus root 2. Remember from the beginning, guys, whenever there's a number being added to the surd, we're going to multiply by the inverse. So it's going to be, we're going to multiply this by 6 minus root 2. And then this will be 6 minus root 2 as well. I'll put this in brackets as well. And let's use FOIL to expand the brackets. So the first terms, 2 times 6 is 12. The outside terms, 2 times negative root 2 is negative 2 root 2. The inside terms, 6 times root 2 is positive 6 root 2. And the outside terms, root 2 times negative root 2 is negative root 4. And then we're going to simplify this. Well, first of all, these two equations are both root 2 equations. These two terms are both root 2's. So negative 2 root 2 plus 6 root 2 is negative 2 plus 6 is 4. So it's going to be 4 root 2. So 12 plus 4 root 2 minus root 4. And root 4 is just 2. So it's going to be 12 plus 4 root 2 minus 2. And I can combine the 2 and the negative 2. So that makes 10. So it's going to be 10 plus 4 root 2. So that's our numerator. Perfectly simplified. Now let's do our denominator. It's the same thing. We're going to use FOIL. So the first terms, 6 times 6 is 36. The outside term, 6 times negative root 2 is negative 6 root 2. The inside terms, root 2 times 6 is positive 6 root 2. And root 2 times negative root 2 is negative root 4. These are both root 2 terms. Negative 6 root 2 plus 6 root 2 is nothing. They cancel out. So it's just 36 minus root 4. And the square root of 4 is just 2, so it's going to be 36 minus 2, which is 34. So our numerator is 10 plus 4 root 2. Our denominator is 34. Oh, lovely, guys. We have rationalized our denominator. And then, well, because now there's no more surd on our denominator, and we have 3 terms, perhaps we can simplify. We can divide each of 10, 4, and 34 by 2. So it'll be 5 plus 2 root 2 over 17. And our answer should be in the form of a plus b root 2 over c. And here we go. A plus 2 is b root 2 over c. So that's our answer, guys. 5 plus 2 root 2 over 17, where A is 5, B is 2, and C is 17. Next problem, guys. A shed has dimensions of height of root 5, width of root 6, and length of 9 over root 2. Find the volume of the shed. Give your answer in the form of A root 15, where A is the integer. So we have to basically find the volume of the shed. I like to first ignore the form that they want to give our answer in. Let's leave that till the end. Let's just first focus on finding the volume of the shed. Well, the shed is probably a cuboid, so let's draw it out. We know it has a height of root 5, a width of root 6, and a length of 9 over root 2. In order to find a volume of a cuboid, we just do the width times the height times the length. So what we're going to do is root 5 times root 6 times 9 over root 2. So 5 times root 6 is root 30, so it's root 30 times 9 over root 2. If this is a fraction, let's turn root 30 into a fraction. So to turn any whole number, or to turn any number into a fraction, we'll make it over 1. And then root 30 times 9 is 9 root 30, and 1 times root 2 is root 2. And that's our volume. But now they ask us to give our answer in the form of A root 15. So we have to turn this expression into A root 15. Well, here we have a fraction. As we can see, the denominator is irrational. So it makes sense that we should rationalize the denominator. So let's multiply both sides by root 2. I'll put the answer down here. So 9 root 30 times root 2 is 9 root 60. And root 2 times root 2 is root 4. And then we can simplify root 4 into 9 root 60 over 2. So, we're not done yet because we have to do A root 15. We don't want a fraction. So maybe we can simplify this surd here, root 60, 9 root 60. So I'm going to do that on top. We're going to simplify 9 root 60. So I can break down root 60 into root 15 and root 4. And we can square root root 4 into 2. And root 15 stays where it is. So it's going to be 9 from the 9 down here times root 15 times root 2, which will be 18 times root 15. And we'll bring the 2 down. And then 18 divided by 2, we can divide both numbers by 2, so it's 9 over 1. So it's 9 root 15 over 1. And any expression over 1 is itself, so it's going to be 9 root 15. And this is our answer, guys. A is 9, and it's being multiplied by root 15. So the trick in this problem, guys, is to ignore the form they want you to give their answer in. First, focus on finding the volume, which we got over here. And then after we find the volume, then focus on finding the form by noticing, okay, this is a fraction, but denominator is irrational. It makes sense to rationalize it. So we multiply both sides by root 2, which gives us 9 root 60 over root 4. Root 4 simplifies to 2. Then we simplified the numerator up here. So you guys should know how to simplify. If you're watching this video, you think of two numbers that multiply to root 60, where one of the numbers is a rational number, so root 4. So it would be root 4 is 2 times root 15 times 9, which is 18 root 15. And I brought the 2 back to here. And we can divide both sides by 2, leaving us with 9 root 15. Given that 10 minus root 32 over root 2 is equal to a plus b over root 2, where a and b are integers, find the values of a and b. So essentially, we have to turn this into this. In this question, we have to rationalize the denominator, even though it doesn't say explicitly to rationalize. But here's how I know. In this expression here, there's a denominator with a surd, so it's irrational. But in this format here, there's no denominator, so it's quite clear that we have to rationalize the denominator. So let's write out our expression. So here, it's just root 2 by itself. We're gonna multiply both sides by root 2 times root 2. I'll put some brackets times root 2. So we're gonna have to multiply root 2 by 10 and root 32. So 10 times root 2 is 10 root 2, and root 32 times root 2 is root 64. So minus root 64 over, and root 2 times root 2 is root 4. Okay, let's try and simplify this. So 10 root 2 minus the square root of 64 is 8. And the square root of 4 is 2. Then I have 3 terms. I can divide all 10, 8, and 2 all by 2. So this becomes 5, this becomes 4, and this becomes 1. So it's 5 root 2 minus 4 over 1. And anything over 1 is itself. So 5 root 2 minus 4. Now let's compare this to this. Well, here they want the integer first and then the surd. So we're going to have to rearrange this. So we can say negative 4 plus 5 root 2. So what we're doing is we're flipping the negative 4 and the 5 root 2. And the 5 root 2 is positive 5 root 2, so it becomes plus 5 root 2. And this is our answer, guys. So A is equal to negative 4, and B is equal to, well, B is the number in front of the root 2, which is just 5. So in this question, it didn't explicitly say to rationalize the denominator, but you should see here, this expression is not rational, and the format they want you to write it in is rational, so you logically have to rationalize the denominator. Rationalize the denominator of 12 over 7 times root 3. So whenever there's a number being multiplied by the surd, we're going to multiply both sides by just the surd. So skip this root 7, just multiply both sides by root 3. So 12 times root 3 is 12 root 3. 7 root 3 times root 3 is going to be 7 root 9. Then we can keep the top the same. And root 9 is the same as 3. The square root of 9 is 3. So 7 times 3. So it's going to be 12 over 3 over 21. And we can simplify 12 and 21 by dividing both sides by 3. So 4 over 7. So 4 root 3 over 7. That's your answer.